to welcome you to my YouTube channel, where you will find Commodore 64 and Atari tutorials available for basic and assembly language programming. This series I'm doing right now is going to be some basic lessons for the Commodore 64. Now, the recent one I did show had to do with ASCII characters and how they kind of work and how you can print, like screen characters in screen memory. What I'm going to do is evolve this a little further, and I'm going to show you how strings, variables, and other such things work, basically known as functions. Now, I did this video earlier and I recorded it. Unfortunately, I never had my Camtasia set up, so it never recorded this part of the screen, so you would have heard everything, but you would have never seen anything, so that would have been useless. So I realized I have to do it over. So it worked out pretty well anyway, because I ran into an issue with the program, so I've got that fixed now, and I wanted to kind of go over that and show it to you. But I also need to reiterate all the other points I explained in the other video. So first of all, I wanted to go and explain, first of all, if you don't know what a variable is, there's two different types of variables. There's numeric and there's string. So if you type in any two-letter combination like VB, and you set it to a value of like 8 or whatever, that's a numeric variable. So if I take VB, it's going to show an 8, and if I want to multiply it by something, I can use it with math. So you got 16, so 8 times 2 is 16. Now, there's another variable called string, so you type the VB, and you type this little $sign after it, which stands for the string. Now this time, if I try to type an 8 in it, and I print it, you're still going to see the 8, but if I try to go calculate this, you'll get an error message, because you can't calculate a string times a numeric variable. So one thing you can do, though, is you can convert this back into another value. And I'm going to kind of skip a step here, but I'll show you anyway. So VB strings right now is showing an 8 in it, but remember that's not numeric. That's actually what's known as an ASCII character. So right now it doesn't know that that's a number. It just thinks of it as you see it at visual 8. But if you take something like instead of another variable called, we'll just call it TR for translate or whatever you want to call it, and you type the word val, I think it stands for valine or something, I forget what the word is, and then you type in VB strings, T is now going to store the numeric component of what the original string was. So if you type in TR, you're still going to get the 8, but this time when you try to multiply it, like before, you'll now be able to calculate it. So now you've turned this string into a number that you can use. Now that can be really helpful in other programs later when you start getting into that. What I wanted to show you was this little text adventure I've been putting together here for the last hour and a half or so here. But first I wanted to explain a few functions you'll see up here at the top, left, rights, and mids. And we'll start by running the program. It's an actual game, but I wanted to stop it to kind of show you and put this stuff in memory so I can show you what's going on. This first variable here you see on line 30 is showing VB strings. So if I type VB strings, it's going to put everything in VB strings inside of here. Now you can put anything, any kind of characters you want in. You can put numbers in here, but it's only going to represent this as an actual string, which means you can't calculate it. You can only display it, basically. And what we're doing in this program is we're actually searching through it. So we're doing something called parsing, which is known as searching through a text variable, or a string variable, excuse me. Okay, so the next thing I wanted to show you, as I said, was the left string. So VB strings is that. So if you want to get the left value of this string, you would type lefts, VB strings, and you would type how many letters you want to see. So this is basically reading over 3 from here. So it's reading the first 3, 1, 2, 3, which would be get. Now the other counter opponent, what you want to call it, is rights. And this will do the opposite. This will read from the opposite side. So 1, 2, 3. So it actually read all 3 of these characters. Now you can also change the length of this and make it read more if you need. Now it's reading all the geographical directions for north, east, south, and west. And there's also one called mids, which stands for middle, which is going to allow you to grab stuff directly down the middle. So what we're going to do is we're going to try to make it read this value here for I and V. So we need to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we need the 10th character, and we only want to read those 3. So now it picked up the inventory. And the reason why this is helpful is when you're doing something like a text adventure, you could pick out any of these commands you want. You don't have to sit there and do something like if keys that you type in is equal to inventory, then we do something basically. That way, it saves you a lot of having to type in all this IV and all this other stuff you want, and just read them directly. I like to read them directly from a variable, a string variable. So this is what this program is doing. I'll kind of explain it to you step by step here as we go through it. There is another command, I didn't want to miss it here, it's called Str Strings. It basically just takes a numbered value and just turns it into a number. There's a really whole lot you can really do with Str Strings. Actually, I said a number, I meant this would actually be T string, excuse me. It goes Str Strings number. So it basically took the T strings and turns it into a number basically. So it's kind of similar to the val line statement. So if we take T strings, now we've got T strings as a numerical value. We still can't go T strings times the value because it won't let you do this. It doesn't understand this. But it is representing this now as a string. So, or not a string, is a number, whatever. Okay, so the next thing down here is I set up another variable here. I wanted to go down to the next line called OB, which stands for object. This is going to represent all the objects you can see in what's called a text adventure or an Infocom adventure. They called them back in the days, adventure games. And to keep in mind, a text adventure game doesn't usually have any graphics. In the old days, Infocom, which is a famous text adventure company, they made a lot of text adventures. You would use everything with storylines. So let me run this and show you. So basically you would see text on the screen here, and it would respond to commands that you type into the keyboard, which are known as 3 parser commands. So you have the first parse letters here. Parse means to kind of read what these letters are showing, to kind of scan through them. So read book, this one's already programmed in, so it'll basically say what are you trying to read, and it doesn't understand the whole concept of the book unless you type a little bit, give it a little bit more information. Actually, that one was working earlier, but it's not working now, so I'll need to go back and check why that one's not working. But that's basically what that does on the OB strings. It's storing an object in there. And then the next thing here says go sub 5010, so let's go and look at that line here. Damn it, I forgot to start it. Having a bad night. This is going to drive me freaking nuts tonight. Hello everyone, my name is Steve. I want to welcome you to my YouTube channel where you'll find Commodore 64 and Atari tutorial programs for basic and assembly language. This series is focusing on the Commodore 64, and I'm going through what are called basic programming lessons. I wanted to kind of teach people some of the basics that you can learn about programming. And I'm going to show you right now how to use these commands and use them in an actual game that I designed here, which is in a text adventure type series here. So what we're going to do is we're going to kind of go through that, and I'll show you how this works. Okay, first I wanted to kind of explain something you'll need to understand, which is what are variables and what are numeric variables. So if you go over here, I'll just set up any variable here. We'll set verb to a value, not to a value, to a number basically. So now if we type print VB, we'll see there's a 12 in it. And we could take this 12 and we could do math with it basically. So if I take VB divided by 2, it'll say 6 because 12 divided by 2 is 6. If we also say VB times a number, it'll calculate it like it's math basically. So now it's 24. So 12 times 2 is going to be 24. So that's basically what that is. That's a numerical variable. Then we have what's called a string variable here. Let me see if the other one's still in memory here. Alright, so we got this in memory. So this is basically showing you what this value is in memory. So if we type VB strings equals a value here, it'll show you what's in there. Type it out right here. So it's got get in it. Now if I try to take VB strings and stick a number in it, we'll still be able to do that. Notice it'll still have the number 3 in it. My computer's running really slow, so it's really hard to type on the keyboard here or something. So it's a 3, but if I try to take print VB strings times this number, it won't work because you can't calculate a string times numerical variable. So what you need to do is you need to convert this. I did show this earlier several times, believe it or not, and I had to redo the video over and over again. But this is my last attempt, hopefully, to get this to work successfully. And now what we're going to do is we're going to turn this 3 into a value that we can use for math. And I'll show you how to do this. It's another command here. It's called val, or valine. I think it's called valine. So we take t equals, we'll just say tr for like translate or convert. You're going to use like cn for convert. And then we'll say valine VB strings. And now if I print cn, you'll see it's still got the 3 in, because remember, that's what was originally stored in the VB strings up here. And what we're going to do is now we can use cn and we can calculate with it. So now we turn this into a numerical variable that we can work with. So that's kind of how valine works. Another thing you'll want to notice here, is the lefts command. And I'll show you how that works. Let's go to the line here in 30. And we'll put it in immediate mode so we can kind of stick it in memory here. So if I type in print VB strings, it shows all the different commands for our program. Now if you type print lefts VB strings, comma 3, what it's doing is it's reading the first 3 variables of the leftmost string. So 1, 2, 3 would read get. So if I change this to something else, it'll still figure out whatever it's reading. So now it's just reading the next letter in sequence, which is a 4. I put 45, I'm going to put 5. 5. And see how it's just reading the next letters in? 6. So now you've got all those first 3 letters. Now there's another command called write, or write string. Remember the $ is a string. And then we're going to read the 3 characters on the end. So notice it read these 3 characters. And we can still read any more characters we want, but it's only going to read them to the right of that variable. So now it reads in all the directional ones there. And however many we go up to is how many it's just going to keep reading. So just add the next one on there, which was a V there. Remember, it's just basically reading from the right going back, while this is reading from the left going forward. That's basically all those are doing at that point. So, okay, now there's another one here. Don't want to lose you yet, but it's called mid, or mid string. So what we do is we say print mid, put the variable name in, and then we're going to make it read a variable here, or a center part here in the middle. So we'll say 1, 2, 3, 4, 5, 6, 7. And maybe the 7th character in the 3rd should say REA. And there it is. It picked up the REA. So it's basically picking up short for read. You just use 3 character combinations. Those were common back in the days. So it's picking up read, or we can make it read anywhere we want in here, just by making it figure out where the next sequence is, which would be 10 in this case, to read the inventory. And obviously, if you want to go backward from the 7, you just kind of figure out where it's at in the program. Oops, I said 3. I meant to say 3. So what did I do here? I did 1. Oh, 1 is at. Oh, this. What did I do wrong here? So let's see. I'm trying to make it read the next sequence. I think it's 3, 3. Oh no, it's 4, 3. It's the 4th character over. So there it is. There's the look. So that's how you make it kind of jump through and figure out what it's doing here. And that's essential to understanding this program I've created, which is the text adventure. You'll see I use a lot of lefts, mids, and all that stuff down in here. I'll kind of go over that and show that to you, although I am pressed for time right now. So let's get started on it. This one's going to clear the screen. I showed that in other videos. You just basically press the home, or press the shift key down and press the home key, and you'll get that clear screen character. This sets the variable string for our verbs, and this is the object, which is basically, in text adventures, you have a lot of objects that could be lying around a room, like a book or a sword, whatever you can see, lying around, and you can actually manipulate them by sticking them in here and making the program read them that way. Okay, so that before it starts here, after it reads variables, it goes to line 5010 to read the story. So if I go to 5010, you'll see what it does here. Right here it says you are in a throne room once upon a time. So it basically shows the first room that we're going to enter in. It goes down here to the return, and it goes back, so it doesn't hit the next line. Return means it'll send it back to where it came from, right after the go sub. So right here, 5010, it'll read the story and go down, and now it's going to wait for input. So input ends. I'll show you in media mode. Basically, well, it won't work in immediate mode, but if I run it here, you'll see it. That little question mark there is the input in, so it's waiting for a response here. So I have to do something with the keyboard, or it'll keep waiting for a response. And as soon as I type something, of course, it'll respond to what I did. So, gotta jump out of the program again here. Okay, so the next line down here after the input is go sub 4000. This one's a little bit more trickier, and it'll probably involve understanding what the input's doing here. But if you look here, it says for a equals 1 to the length len of ends. Let's look at ends again here. Oh, actually, I don't have anything. Let's put something in ends because I had to stop it earlier. But we'll just say that we were at the program, we ran it, and we typed in read book. And we'll go back to 4000 here, and I'll show you what's going on. So now I stored read book inside of the variable end, like you saw me earlier. I can stick any string characters I want in there. And 4000 says for a equals 1 to the length of I in string. So basically what it's saying is go through this end statement and loop through it until you get to the end of it. So basically it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 and get to the end. That's what len means. It means the length of how long the string is. So start from A, 1, 2, and count all the way up to the length. So if we type in print len I in strings, it'll tell you how long that string is. So it basically means it's 9 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's reading all 9 there. Now look at this next line here. It's a condition that says if mid-end strings a comma 1 equals, and it shows a quote, and it shows a space and another quote, then sp equals a. Now what I did in this case is I'm making it check for a space so I know the next sequencing character to read for the text adventure. And the reason why I did that, because if you're typing in 2 words here, you want to be able to read in what this second one is, because sometimes the second word might be, the first word might be longer or something. You might type in attack, monster, or something like that. And instead of just trying to read the first 3 characters, if we read the next 3 characters, it's not going to be correct. So the best way they did it in the old days, they check for the space and they read the next character. That was real common back in the days. So let's go here and look at that again. So it picks up the space. Once it gets a space, it records it. And I told you earlier, the numerical value of sp equals a. So what this is saying, let's go back and we'll look at our ends again here. It's read book. Now if we're reading through here, we'll check for a space and then we're going to calculate what sp is. So we can redo this right now and I'll show you what sp is equal to. So you go 1, 2, 3, 4, 5. So sp will equal 5. Remember, that's only a space. It was checking for the space. What we want to do next is we want to move it up one more number, so that, or no, one more string character, so we can read the correct value, which would be the first word of the second parse command, which is the object, verb object, or verb noun, excuse me. It goes to verb noun. So the next thing would be to take the variable. I just set up a new variable here called ob. Take the original value that was stored in sp, which remember earlier was 5, and just add a 1 to it so we can pick up the next character, which would be the beginning of the next parsed command. So I'll show you how that works here and why it's essential. We'll get down, actually, let me show you that now, because if I probably jump ahead, I might not remember to go back there. So I'll do it right now. I'll have to jump ahead a little bit in the program to show you where I did that and how I checked it. So I think it's right here. Let's see, ob strings 1, 3. Let's see. First one checks for the read. The second one checks for the read book. The next one, I think it's this one right here. It's this one. It's 200. So let's go to 200 and read 200 off here. If left of end strings, remember we've got our end strings still here, comma 3. So let's print this out and look at this, how the computer would see this. Left end strings, comma 3, comma mid strings, VV string 7, comma 3, and see what it shows. So basically what it's saying is if the first word you typed in was REA, the first 3 letters, right there, the left first 3 letters of 3, which is correct, is equal to the verb statement we set up, and we're picking out the middle value, so we're looking for that command, REA, inside the string variable. Then, if that's correct, we're also going to check this next one, which says mids, ends, ob strings, comma 3. So let's print that. It probably won't work here because we haven't actually entered it inside the parsed program, but let's see what happens anyway. I'm just curious. Oh, I tried to stick a, you can't stick aside a numeric inside of a midge. It has to be a variable. So actually it did work here. So it picked up the next part we needed, which was the book, as I indicated earlier. Now if we go down here and we print OB, I'll show you, it should be a 6. So see, it's a 6. If you count here 1, 2, 3, 4, 5, 6, it picked up the 6th character, and then from there, remember this is 6, so this would be 6, 3, it picks up the next 3, 1, 2, 3, which is the book. So the way this translates is say mids, in strings, 6, 3, which does the same thing, and that's how it makes it scan for the character in there. Okay, so let's go to 170. I know I jumped over the other one, but I wanted to show you. Well, let's make sure I didn't do, if I did 4,000 per, yeah, that was the parsed one. So let's go to 170, and then we'll check this one next. And you can just, again, print them out like I'm doing here to kind of check them once you run the program. And check the D64 file to see what's going on. So this again, right here, this time it's reading for, it's looking for read, and it's looking for the next variable command here. Let's see, read left, okay, read the first character would be, let's see what my ends equals here. Something doesn't look right here to me. Read book. So if left things you typed in was read, the verb is 4, 3. Oh, this should be OB string. This shouldn't be that. I'm trying to make it read the book instead. I was making it read through the verb. That one it makes. Well, this is actually correct because it's still reading up the read. But this is only checking for the read statement is what this is doing. So this is saying that the command you type in is verb, and then we need to match this not to the verb but to the object. It probably erased it here, but let's see. Yeah, it erases every time you try to do it real time. So if we type in read book, it'll say, what are you trying to read there? So that's basically what that's doing. Hopefully if you follow these, you can kind of see it step by step what these are doing and kind of read through them here. You just have to, again, just take them apart like this to see what's really going on. And then print the next one beside it. And look at them side by side. Oops, I put 30. That's actually read all of them there. Let me erase this so I can show you what's going on with this. So this one said, did I erase my input again? I think I did. Yeah, I'd have to run the game to really show you on that one. But let's stop it here so I can kind of, I need to type in a command first so it can read in the input. Now it's got the input read. Now we should be able to go through and look at that command. Now it's going to be able to read that command and respond to what you typed in to the parser or the input statement. And then we'll print out these as actual data that we can see. Did my input get erased again? I think it did. Or I didn't have time to process it or something. It's like, because when I'm trying to run this, I'm trying to stop it at the same time I'm hitting enter, and it's going into another part of the program or something. It should be reading this input. There it goes finally. Okay, so I was trying to get it in there. Now let's go to 180 and do it again. Print lefts, ends, 3, mids, VB string 7, 3. And you'll see it's got a match on the read now. So now it's just saying if you just type in read, then it's going to say what are you trying to read there, and kind of move on. So the next line here is very similar. What is it? It's 200. Again, we can kind of print it out again. Easiest way to see it. And see where what it's doing now. So it's reading the read. We know it was going to do that. Now it's going to say, is this command equal to the OB string? So this one you have to print out again. Ends, OB, 3, mids, OB strings 1, 3, and we'll see what it's reading here. Of course, I could end this one correctly. So it's saying read book. So if you're reading book, it should go this next line. But this one apparently isn't working right now. I had it working earlier. I don't know why it's not working now, but that's what it's supposed to do. It's supposed to read the book. But if we type in REABOO, it doesn't want to. It's just gonna. It reads the first one. It kind of skips the second one. So I'm not going to go back and try to fix it right now, but maybe later I'll get it fixed and I'll upload it to the D64 file. We'll just move on to the next one here. Let's make sure we still got our ends again. So we have to go through all that again. Okay, erased it again. So let's type in read book. Come on. I'm trying to stop it before it goes to the next line. It's going too fast. Because every time I hit enter, it's just going to show nothing. So I say read book. It's slowing down my computer. I don't like this. Okay, let's see if I got it this time. Okay, now it's in there. Now we can check it again. Now we go to the 210, and we can print out to see what the next one's doing here. Kind of read what the next command would be up to. So this one is interesting. It's saying this left strings R is equal to W. That doesn't make any sense. What this is going to do is it's going to pick up a direction. I'll show you how this works. It allows you to move around from screen to screen. So in this example, I'm just going to type in an E. I'm going to try to stop it here so I can get back to the, there we go. So I could see what's going on here underneath. And we'll go back and we'll do it again here. In strings, comma 1. So remember, this is only going to pick up the first character inside your input statement that you type in. Which at that point, we only typed in one value anyway. But that's all we want to do is we only wanted to check the first one and nothing else. So it's checking for the E. Does it match the W? If it did, if E matched the E, it would actually allow you to go to the next room. But because it's not the W, it didn't do anything. But the next line down, I think this is the one that actually does match correctly. Let's see. Oh boy, come on, give me a break here. Okay, so there you see E is equal to E. So basically it's saying what you typed into your input statement. Remember your input, this is your input ends that you type in. And it's going to show that question mark for whatever you type in right after here. If this is equal to an E and it matches what's in our verb, so that means we're moving, then we're going to be able to make it move from screen to screen. So this says go to 6010. And let's look at that line again. And let's go to 6010 and see what it's going to do. It's going to basically go down here. This is going to show you a new part of the program I wanted to show you. This is going to calculate, first of all, it's going to keep track of which room you're in. RM is standing for room, and it's going to display which room you're in. And each time it's in a certain room, it's going to show different messages. So if the RM equals 0, then it's going to go to 5010. If you look at 5010 down onward, it's going to say you're in the throne room. It's going to print all the other messages for that. If RM equals 1, then it's 5130. So if we go down to 5130, then you are in the main hall. If RM equals 2, then this is when I added later, then 5160, which means you're on the drawbridge. You're on the bridge there. So it's basically telling you which room you're in. Now this next line here is really interesting. This is keeping track of what is going on with your west and your east direction. This is called boolean math. I wanted to show you this real time, how this works. Let me just kind of list it back to the screen here and list 2000. I had to play with it to get this one to work earlier. This is what I was trying to tell you about earlier. I couldn't get it to work properly. I'm glad it didn't record properly because it took me a while before I finally realized I didn't even put in the command I needed. And this is going to keep track of whatever you type into that input statement. And then we want to print out the room to kind of figure out what the room is. So right now Str Strings is reading ends. Ends is showing an east in it. So what it's doing here is that actually subtracting backward. You can't tell, but that's -5, -6, so it's going backward. So if I go up here, and if let's say we type in input, and we type in west, for example, now it's going to increase it and bring it back to 0 here in a second. You'll see it go to 0. Now it's at 0. Now it's going to keep increasing. Let me erase this so you can see this. It's going to keep increasing every time you type in the west in the line. It's going to keep increasing. This is how you get it to move through the rooms. It's kind of a trick you can use because what it's doing is to say room equals room plus 1 times ABS, which means the absolute value, which is going to remove all the negative signs in it so you get a positive number. And inside of here you see SV string equals W. So this is basically checking for boolean to see, did you type in a W in your input statement? If you did, add a 1 to it. So if we type in W here, you see how it's increasing it every time? And then the next thing here, you'll see it right after it says -1 times the absolute value. And this time we're saying SV strings equals east. So it's saying, did you type an east in it? If you did, subtract it backwards. So now if I type in east, you'll see this number counting down. Watch. Now it's going backward. That's a trick I used and I learned years ago, how to move around without having to type in stuff like if room equals 1, then, or room equals 1, then something like x equals x plus 1 or whatever. Just basically to move you through the rooms. That would move you through one room. And it would say, well, I'm saying if room equals 1. I meant to say if ends, the inputs that you type into the keyboard, is equal to, what was it, east, then that would move you through one time there. Then room equals room. We're going to reset it doing it this way, but I wanted to show you kind of how it works real time there. Room equals room plus 1. So now you'll see if I type in here print rm, it's going to keep track of what is in rm. So right now it's increasing because our value is equal to this, but if I put W in it won't increase this because it's not reading input as W. Remember earlier we just set it up here to east. Now if I set this to W, now it'll go down here, and we want to say something like room equals room -1 to make it go backward. Now it's going to subtract it backward here if I done it properly. There it goes. So I'm reading the condition so I can kind of see what the next value is going to be. That's exactly what this is doing up here. It's just a shortcut way of going through without having to have two different lines here. It kind of combines them into one. It's kind of a faster way of getting things done. I liked it. I always like those kind of shortcuts. When you get really good, you can use those in a lot of different things. You can kind of check keystrokes in them and check the joystick inside of it. It saves you a lot of time, but sometimes it does seem to slow down the computer, like in BASIC and stuff like that. So let's go on to the next one here, which was, I think we did 210, right? Let's go to 220. I think I already did all these. These are just the directional movements. Yeah, these are just keeping track of what you type in to what the value is showing. So it's basically, this one here is representing the east and the other one's the west. So if you go to 6010 there, you'll see it's going down here, it's checking the parse commands down there, like I showed you. And then from there, it's going to print out the appropriate room based on whatever this RM value is showing. So if it's 0, it's going to print the message for that. If this turns out to be 1, it's going to print the message for that. If it's 2, it's going to print out the room for that. It's a faster way to get those rooms to show up. And it works pretty good. I think that's basically the gist of the program here. I think I kind of went over everything we could. So let's run it and see what it's doing. So it says you are in a throne room. Gives you the story. You were living, once upon a time you were living in a forest. One day the king approached you and assigned you on a mission. On a table you see a book. I know this is kind of not making a whole lot of sense right now, but basically it's saying you're in the throne room right now. And I could have made this say something, the king in the past approached you with an assignment. You were asked to go do such and such. You're in the throne room. There's a book on the table. And it says, while the king was sleeping, a ring was stolen from his stash. And your whole goal would be basically to find this ring. I didn't add that part in here, but I should say like your goal is to find the ring or something like that. That's what the mission would be actually. I said he put you on a mission, but I didn't say what the mission was, did I? Let's go back to that line here real quick. Approached you and assigned you on a mission. This line will say to recover the ring. Now we run it, we'll see the rest of the message there. So He assigned you a mission to recover the ring. So there we go. I'll kind of clean it up here a little bit. I'm just going to print this on the next line. What you do is you just basically just put a semicolon like this, and it'll just keep this one on the same line. It'll take whatever was here from mission and add this next one right after the mission. Watch, when I run it, it won't go to the next line this time. See, it kind of stuck it right after the mission. It's stuck to recover the ring, so it's on the same line. So it looks kind of clean that way. So we type in east, or west, excuse me. It'll move you through the room. So now you're in the main hall. Now you're on the bridge. There's still something wrong with moving backward, though. I need to probably fix that part. But basically, it is kind of moving you around the way you want. And see how it's switching the rooms as I'm moving around? And it's clearing the screen at the same time. That's because if you look here in the program, you'll see beside this I put the little heart character, so that clears each time it gets to this line, it clears. Each time it gets to this line, it clears, and so on. That's how you clear the messages each time. So that's about it for this program. You're welcome to go ahead and use this at your own advantage, your own leisure, to do what you want with it. Make up your own text adventure. Often back in the days, I would start with a simple shell like this and work it up into a big game. And one in particular I do have that on my channel if you want to view it. It's called Quest for the Mad Bomber, a game I wrote back in the 90s. I actually got $350 for it when I sold it to Lodestar Soft Disk Publishing. Although, now that I look at it, it's pretty sloppy work. I don't know. The program was very complex. I parsed it. I turned off these messages so you couldn't read them. And eventually I found out what I did is I kind of translated. So every time you see like an A or whatever, I might have turned it into a B. If you saw C, I might have turned it into a D. So it's hard for people to read whatever the messages were hidden behind scenes, because I've seen that done before. But the problem was they told me as a soft disk publishing company, if you turn off the messages where people can't read them, people are going to cancel their subscriptions because they want to know what the solution is. A lot of people just want to be able to solve a game and go through it. They don't like the frustration of trying to figure stuff out. But back in the days, that was the whole idea of Infocom Adventures, was to figure it out on yourself, on your own. But because they were obviously, trying to maintain their status and keep their revenue flow going, they had to keep their customers satisfied. So that's the program right there. I'll put it on my website so you guys can go ahead and download it and everything. This night is just about over for me. I wanted to at least get this program out so you guys can kind of check this out and use it for your own advantage. Remember to use those print lefts and understand what they do. And then use the print rights to kind of figure those out too. The same thing, so that you know how they all work, and use obviously the mids to pick up the middle part. So go back and rewind the video if you need to and kind of review it to see if you understand. Ask any questions. I'll always respond to your questions. I do want to thank you guys and for subscribing. For those who've been following my channel, I really enjoy it. This is a big passion for me, so I'll keep going with the basic programming, and I'll keep that Commodore game flowing as fast as I can here, even though my hours have changed dramatically at work. I'll be working a very early shift now. So thanks guys, and look forward to hearing and responding to your questions soon. You guys have a good one.